Hello. Yay, we're on our last section of geometry. And you guys are doing a fantastic job. So let's finish strong. This is probably the most applicable geometry because I really want you guys to be able to know how to find the area, surface area, volume of things like swimming pools, going to Home Depot, so that you're not taken advantage of when you want to put in carpeting or something like that when you get your first apartment. Okay, so we're on section 11. This is topic 1. We're going to bounce around a little bit, so really pay attention to what it is I'm saying, what we're doing next. This section is going to be a lot of video, note-taking, and exploration. It's a lot of fun in class. I am going to try to make it more fun for you at home, and I'm kind of digging around. Me and Mrs. Ogron are going to try to come up with some activities for you to do at home. So bear with me and take good notes and follow directions on Google Classroom very, very carefully. Okay? All right. So we're going to be talking about two-dimensional figures that can be folded, and they're going to be folded into a three-dimensional solid. We all have boxes that we can rip apart at home. You go to put them in the recycling bin, you tear them apart, and you end up actually getting them back to their net stage. So a net is a composition of two-dimensional faces that is formed by unfolding a three-dimensional figure. So we're going to be folding and closing figures. A three-dimensional shape is called a three-dimensional 3D because it has 3 dimensions. Yes, you know these. It has length, it has width, and it has, you got it, height. Put a star next to height. All year long, I've been talking to you height is perpendicular to where you're standing. Later on, we're going to introduce a new height, and I'll let you know when that is going to be. But put a star next to your notes. Height is going to be very important. Three-dimensional solids have 4 components to them. We have what we call the face or faces. And faces also include bases, vertices, and edges. Faces and bases can be mixed in to be the same thing, but because we name the shape on its base, this is how we name the shape, and then the faces become the sides, then we know whether or not it's going to be a prism, a cylinder, or a pyramid. Okay, so let's look at this. Number 1, I want you to take and highlight that special, because number 1 is what shape? Yes, it's a 5-sided shape. It's a pentagon. Notice it's the only pentagon in the picture. That is a face, but more specific, it's the base. When we think of a face, we think of a two-dimensional flat surface. So all of these are faces. They're two-dimensional. They have a length and a width, and they're flat. But because this is the bottom that holds all of these triangles together, we call this the base. These are faces, and they're in triangular shape. And because these are triangles, we know that when this thing gets folded up and it closes, it becomes a pyramid. So I am a terrible artist, and you're going to be so grateful that I found resources for you to use online. But because this has 5 sides, you have 5 triangles, and if I was to stick these triangles up and draw a picture, they would all end up folding and joining at this apex where the base is on the bottom, and these green triangles will stick up at the top. Identify the base. So the base is number 1, and it's a pentagon. And 2, 3, 4, 5, and 6 are the faces. But since the pentagon base is sort of a face, we end up with 6 faces altogether. We designate a base as a face, but I want you to be able to separate out the base. What type of three-dimensional shape is constructed when the net is folded? Again, you always name shape by the base. So this is a pentagon, which would be a pentagonal. And because the sides are triangles, it is a pyramid. Sides are triangles. That's huge, okay? Then we count the edges and the vertices. All right, so the edges are where 2 faces meet. Edges are where 2 faces meet. So the number 1 and number 2 meet right here. So that would be an edge. Where the edges touch is a vertice. Where 1, 2, 3 or more edges meet is a vertex. Okay, so where 2 faces, where 2 flat surfaces meet, we have an edge. If we have 2 plus a third, we end up coming to a point, and that's where it becomes a vertex. All right, so we're going to find out later that there's a special formula that's called Eulers Formula, where the faces plus the vertices will equal the number of edges if you add 2. Faces plus vertices equals edges plus 2. And this formula will help you to count edges because it's easier to pick the faces and edges than it is always to find the vertex, especially when it's opened up in a net. All right, now, when you go to count faces, which is the easiest thing to count, always count your bases, and if it's a pentagon, then you know it's going to have 5 sides with it. Again, let me say that. If you know the base, and in this particular case you have a pentagon, you know that you're going to have at least 1 face for the base, and the number of sides of the base will have that many sides attached to it. And if it's a pyramid, you don't have a second base. So 1 for the base, plus it has 5 sides, gives you 6 faces. And you will have an edge, the number of edges that is equal to the number of sides plus the number on the base. So all of these sides, 5 sides are going to touch at 5 places, plus the sides are going to touch on the bottom. So you're going to have 5 plus 5 equals 10 edges. These two will touch. That's 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And that's why we need to add the plus 2. And we're going to get to that later. Okay, let's move on to the next page. All right. In the videos that you're going to watch that are attached to this lesson, it's going to show you how we know which one of these will become the net that folds up to make a cube. There's a difference between a cube and a cubinoid. Okay, a cube, all the sides are exactly the same length. A cubinoid is really another name for a rectangular prism, but they like to use the word cubinoid, where the bases are squares, but it's elongated and the sides are longer. So we end up calling this a cubinoid or a rectangular prism. Okay, so which ones will fold up? Well, this is where the visualization is kind of tricky. We know that if we start folding this up, we have this gap in the middle. I can't have more than 2 bases. I can't have more than 2 bases. And if I was to fold this up, I would have a base and a base and a third base lined up. And this gap in here is going to tell me if I fold this over and this over and these over, somewhere I'm going to overlap over here and get a hole over here. So this does not fold to make a net. This one, if I roll these sides over and lift this up and lift this up and this over, this one will make a nice net of a box. On the length that I send you, you'll actually get to play and change the pattern to see this. This one, if we start to fold, this will become my left side, and this would be my right side, but then I end up with 2 bases in the same spot. So that's not going to work, because if I fold, 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 I have 4 here, and then this one will overlap on this one. Actually, this does work. This is a face, a face, a face, a face, and this is a base, and this is a base. So these 4 kind of roll together to make the inside sides, and then the 2 bases that holds it together. It's this one that overlaps. If I fold this one up, I have 3 sides, but then these would overlap on the same sides if you're folding them together. So this does not work. Please see the visual, because it doesn't make any sense until you actually see them fold to know what I'm talking about. Just try to picture if I was to roll this over and fold it, these sides would also roll over and fold on top of this one, because this is 3 deep and this one would roll over and actually hit it. So it does not work. Okay, fill in the blanks and draw an example of each one. You're going to see some of these on your Math Nation. They're so important I wanted to do them twice. A blank is a solid geometric figure that has two parallel congruent bases that are connected by lateral faces that are parallelograms. Another word for parallelograms is a rectangle. And because it has two parallel bases, one on the bottom, one on the top, or on the sides, this is called a prism. Okay, two parallel bases, this one and this one will not ever touch. They are parallel to each other. I'm going to highlight these in pink. These are your bases. And then the sides are made out of rectangles. And this is what makes folding it difficult without actual having a model. The bases are pink. We name the shape by its bases, and every single shape that has rectangles from sides are called prisms. Okay, two bases, and if the square has four sides, then the rectangles are going to be four of them. And it's very hard to count, but there's one on the top, one on the bottom, one on the right, and one on the left. So I'll look at it and say left face, right face, top face, and bottom face. Left face, right face, top face, bottom face, where the two bases hold those four rectangles in place. Let me say that again. The bases hold the rectangles in place, and that's how we get a rectangular prism. A blank is a geometric figure formed by connecting polygonal base with a point forming triangular lateral faces. Well, now we've got this thing that has got a point, triangular, lateral. Lateral means sides. That's huge. I had introduced that before. So down the side of your paper, I want you to write the word lateral, because lateral means sides. Okay, lateral means sides. So this is a pyramid. A pyramid is a solid geometric figure connecting the polygonal base, one base, with triangular lateral faces. So even if the base looks like a square, the sides are going to be made out of triangles. Where the base is a square, but the sides are triangles. 1, 2, you can't see it on the back side. 1, this would be the front, this would be the right, the one in the back would be the back, and the one on this side would be the left face. So if the square is on the bottom and it has triangles for sides, this is a right pyramid or a square pyramid. You name it by its base, square, and the shape, because it comes to a point at the top and these sides are triangles, it's a pyramid. Square pyramid. A pyramid has lateral faces that are triangles, lateral sides that are triangles with a point at the top, and we call this the apex, or it has one vertex. Okay, a blank is a solid geometric figure that is composed of two parallel congruent circles. So now we have two parallel congruent circles with a rectangular lateral face. Well, when I draw in the lateral, meaning sides, and we have two bases that are circles and that are parallel, we end up with this thing that's called a cylinder. And a cylinder doesn't really have a rectangle, but when we open it and cut this non-ending seam, we end up with a shape that looks more like this. Where my bases are definitely circles. And when we go to roll this object up, you can do this with different canisters at home, but you'll see that the bases hold this side together. And we can't really call it a circular prism because polygons don't have circles, so a polyhedron, a many-sided shape that's enclosed. These are polyhedrons, by the way. Many polyhedron closed shape. This has a special name because it's curved, and we call that a cylinder. Opened up, it looks like this. Okay, so make sure you're watching the visuals. These are on the links. These help you to open and close and see them all. Okay. And then we have a blank is a solid geometric figure that has a flat base, frequently though not necessarily a circle, and it tapers to a point called the apex or the vertex. So this is a cone if the base is circular and it comes to a point. Okay, versus a pyramid that comes with any shape but a circle. A pyramid has rectangles for sides, and any shape can be at the bottom, square, hexagon, it could be a pentagonal pyramid, but the sides are triangular. A cone is got a circular base, and again, it's not a polyhedron, that's why we call it a cone. And these sides don't really necessarily look like triangles when you open it. It'll look more like this when you open it with a circular base. But it comes to this point. So the face of this kind of looks like, let me do a different color. the sides of this, or the lateral area, looks more like a pyramid, but the base is circular, so we definitely call that a cone. And it comes to an apex or a point. Okay? All right. So looking at the first example, what type of three-dimensional shape? Notice that these are all the sides, the faces. It has 1, 2, 3, 4, 5 faces. This happens to be the base, because you can only have 1 or 2 bases. And because it's a square, and because the sides are triangles, this is a square pyramid. And the name always has the base first and then sides. Okay, so when you get to something like this where it all looks like rectangles, you have to ask yourself, is there any two that are exactly the same? And the only two that are exactly the same are these two. This one and this one. And the sides, 1, 2, 3, 4 of them, are rectangles. So this is a rectangular prism. Okay. Some of us might say, hey, these two are exactly the same. But then you would have 1, 2, 3, 4 sides that are different, but they're still rectangles. So this particular shape, put a star next to it. It can be called a rectangular prism no matter which two you pick as your base. And I want you to think of that as a book. If I said to you, look at this book, you would say, hey, this face and this face are the same, so these are my bases. Or I could have the book this way, and this face and this face would be the same. So rectangular prisms are probably the trickiest to figure out which is your base and which are your face. But I always like to look for the two that are holding the other sides together. These two appear to be holding these sides together. Okay, this one is pretty easy. Which two are exactly the same? And these are the triangles. So these are my bases. And these are my faces. Notice, if the base has 3 sides, then you have 3 sides attached to it. If the base has 4 sides, then it has 4 sides attached to it. If the base has 4 sides, then it has 4 triangles attached to it. That'll help you to be able to count the number of total faces. 3 plus 2 is 5. 4 plus 4, 1, 2, 3, 4 plus 2 bases is 6. 4 plus 1 base is 5. Let me do that again. 3 plus 2 bases is 5. 4 plus 2 bases is 6. 4 plus 1 base is 5. All right, next one. There's only one base. Again, you have triangles. So what do you think this is called? Looking at this shape, what do you have? Yes, you're right. That is a hexagon. And the sides are all made out of triangles. So it's going to come to an apex or a point. So this is a hexagonal. Not a prism, but a pyramid. Okay, if it's hexagon, you know it's going to have 6 sides. 1, 2, 3, 4, 5, 6. 6 plus 1 base for a total of 7 faces. Okay, this is curved, so we know it's not a pyramid, even though it comes to an apex, and this is a circle, so this must be a cone. 1 base, this is a cone. 2 bases and circles, this is a cylinder. And you guys are sticking with me. I know it's a long video, but this is 2 days worth, okay? Look at this one. Again, we have 2 bases. And always identify the bases first. The bases hold all the sides. Since it's a hexagon, you know you're going to have 6 sides and 2 bases for a total of 8 faces. And then when I want you to think about what this shape would look like if it was closed up. I was stumbling earlier trying to explain to you faces, edges. Let's pretend that these were the same. If I close that up, you know that you're going to have 6 edges up top, 6 edges on the bottom, and then your sides would be connected. So if you have 6 on the top and 6 on the bottom, and you're going to have 1, 2, 3, 4, 5, 6 on the sides, you have a total of 18 edges. And earlier I said that faces plus vertices equals edges plus 2. Okay, so let's count the faces. We knew there was 8 faces, 6 sides, 2 bases, that was 8, plus vertices. Vertices are where 3 or more edges meet, 1, 2, and 3. We have how many vertices there? Well, 6 on the top and 6 on the bottom for 12 vertices. 6 on the top, 6 on the bottom. Edges, we just counted the edges as 6 on the top, 6 on the bottom, and 6 around the side. 6, 6, and 6 was 18. So 8 plus 12 is 20. 18 plus 2 is 20. So we have a total of 20 equals 20. And this is called Euler's formula. Okay, it is much easier to count a shape when it's closed than it is to count when it's open. So I wanted you to see that if you could visualize it closed, the edges are simple to count. If it's 5 edges, it's 5, 5, and 5 in the middle. If it's 4, it's a square, it's 4, 4, 4. You can always find these edges very easily by looking at the bases. You're going to have an edge for every side of the shape. If it has one base and it looks more like a hexagonal pyramid, it'll all come to a point. And the edges are simply 6 on the bottom and 6 on the sides. Vertices, 6 on the bottom, and how many on the top? Only 1 on the top. So 6 plus 1, 7 vertices. Faces, 6 on the side and 1 on the bottom. So then we have 7 faces. Edges plus 2 equals the faces plus vertices. 12 plus 2 equals 7 plus 7. Okay? And then you can go ahead and answer the question. Select all the statements that apply to the figure. The figure shows a net of a hexagonal prism. Prism, is it rectangles? Prism, rectangles, is it hexagonal? Yes. The areas of each two-dimensional section of the figure add up to the surface area of the hexagon. The areas of each two-dimensional section of the figure add up. So would I add this area plus this area plus this, and this? Would that give me the area, the height of the solids? I want you to finish this on your own. Watch your Math Nation. You guys were amazing. I know I talked for a long time today. Have a great day. Enjoy the long weekend. You'll have an opportunity to go through all of these sites. This is the foundation of everything we're learning in this section. Watch your Math Nation. Watch, play with the manipulatives, and get ready to get started on Monday. Have a great weekend, guys. Bye.